Hello all, welcome to another session from We Are Learning. Today we'll be seeing some basics of statistics, mostly about uh, measures of central tendency and variance and standard deviation. These are fundamentals to build your knowledge more on any data science or analytics that you will be going through. So let's deep dive into these basics. So what is statistics? Uh, it could be a discipline which concerns about some collection, organization, analysis, and you interpret and then you present the data. The history goes back almost 1749 in Germany, and many other European mathematicians contributed a lot. To me, to put it very simple, it is a collection of facts to conduct a meaningful research. That's all about. So to do this, there are few criterias which has to be very clear when you get a data set from which you can do a thorough good research. So the first thing that I believe that we should be very clear is about central tendency. Many people know about mean, median, mode, but we'll just try to clarify by its definition. So mode is a value that occurs most frequently in a data set. Okay, so frequency is the number of times it happens in your observation. For instance, I have taken some example and you could see 6 occurs most of the time compared to any other data in this set. So the mode is 6 out of this example. If I have to find a median out of the data set, as the name implies, it is the middle part. So if you take a data observation and you can maintain it from in an ascending order, which will be very nice to clean the data first, set it up in ascending order, and then find your mode. Your median will be the exact half. So that means in your observation, in your data set, your median, if you identify a median, there is an exact half above your median and an exact half below your median. In the given example, you could see 1, 2, 3 is above 4 and 5, 6, 7 is below 4. So 4 is our median. Mean is a very common term that we use in our day-to-day life. It's nothing but averages. This is identified by summing all the data in your observation by dividing by the number of observation that you have. For example, you have 1, 2, 3, 4, 5. The total is 15, and you divide by the number of observation 5. So the average is 3. So average plays a very major role in stats. When you're trying to predict, you're trying to take a sample from a population, trying to find the average, and then trying to understand whether your sample is near to the mean of the entire population so that your prediction can be correct. Say, for instance, you are in a production unit. Uh, they produce water bottles. Yes. So every water bottle contains 200 ml of water, for instance. And I want to understand, I cannot, because this is a continuous factor, you cannot take the entire population, correct? So you will take a sample, maybe a 10 bottles you take out of maybe 40 bottles that has been produced on that day. And if I sample the 10 bottles and the average looks to be somewhere around 199 ml or maybe 201 ml, that is very near to the 200 ml. Okay, that means I'm falling in the near the mean. That means my sample should be correct and hence my population should be correct. So all the bottles that I'm filling should be 200 ml. So that's the understanding about mean, and that's how you can explore a lot and lot when you are very clear about what is a mode, median, and a mean. With that, we'll try to understand two other parameters. One is variance and another is standard deviation. So what is variance? As the name implies, how much it varies from your mean, to be very simple terms if you put it. If you put it by a definition, it is the average squared deviation from the mean. Okay, from the given set of observation, and you have a formula S square xi. I is the number of observations that can happen. So if we have 10 observations in the data set, then I will be x1, x2, x3 till x10, and then x bar is the mean. N is the number of observation. We can never get in a real-time situation, we can never get the entire population. So we always consider whatever we have as a data set or as an observation is part of the population, and hence it is called a sample. And always you would see the denominator to be n minus 1. If you know the entire population, then you can substitute this by n, which is the total number of observation in the population. But in a real-time situation, that never happens. What is the use of variance and the standard deviation? I will explain it by an example, but as a theory, as a definition, please understand this is your average square distance from the mean. Okay, and this is the formula that you have. Standard deviation is nothing but the squared root of variance. Okay, so I already have a variance and I know if my sample set is how much deviated from my mean with the help of variance. Why should I take a square root of it? Why a standard deviation is even required? The problem with the variance is um, if you take a mean as 0, okay, your variance can be in the plus 1, your variance can be in the minus 1, and the data set that you're getting can be in the variance of minus 2.5, can be in the variance of plus 2.5. So if you have number of samples, okay, and you got the variances from where it is differing from your mean, and if you're trying to compute that, it becomes 0. So you can never apply a mathematical calculation over a variance, and that's why you need a standard deviation. So when you do a square root of it, means you're bringing the square deviation back to the normal deviation. You eliminate the factor of the sign. Okay, minus 2 square is 4, becomes positive for you, right? So you eliminate the impact of the signs, and hence it becomes a computable figure which can be used in the mathematical calculation, and standard deviation has been used almost everywhere in the statistics, and which applies in your data analysis, data science, artificial intelligence, wherever you're trying to do. I'm not sure about artificial intelligence, but definitely in data science and analytics, you definitely use that. So by example, by definition, standard deviation is the positive square root of variance in the given set of observation. And I have explained it about the signs, and this is the formula that you have. So I use the number of observation you have in the data set, and n is the maximum. And as I told you, we will never get n the entire population. So we always understand the data set that we got from our observation is a sample. So it is n minus 1. Now that we know what is variance and what is standard deviation by a definition, we will try to understand where it actually applies. In a real-time situation, what happens is we have to know the given sample set, what you have, is normally distributed or not. Okay. So if your data set is normally distributed, that means the samples that you're trying to pick is in either the both the symmetric side of normal distribution that you have. It's very easy to understand where your sample lies, and when you're trying to predict some factors about it, it is very useful. Trying to get the next slide. Okay, so this is a normal distribution. You could see both the sides are symmetric, and if you think this is your entire population and you are trying to identify your sample that you picked to measure is in either side of the symmetric sides, okay, and the tail never touches the line, it's infinity. That's the assumption. So in a given normal distribution, my mean and my median and my mode should be the same. This is the assumption. Okay, now if I take any sample out of it, I should definitely understand whether the sample that I measured is how much distance from a mean, so that I know if the sample has been taken and it is okay with my process. Like the same water bottle that you take, you have taken 10 out of the 40 and you measured it, and suppose it's not 200 ml. Okay, the mean becomes, say for instance, 205 ml. So 5 ml is very much higher deviated from your mean. So whether the sample is correct or not, right? And second time, then you take a sample, it may be 199, and then you will try to understand, yes, 199 is very nearer to 200 ml, maybe this part of the sample is part of very near to the mean. So you can do various calculations out of it. Yes. So let's try to take two data set. I have taken a data set with some numbers. You can see 1 2 3 4 5 6 7 8 9 10 11 another 6. Okay, so the total number of observations that I have here is 12. Okay, and then you can see another data set 4 5 6 7 8 and 6. The similarity between these two data sets, if you see, the total is 72 and the data set 2 is 36, but you can see the mean, the median, and the mode is same for both the data sets, correct? So your mean is 6 in my data set 1, same in data set 2, median is 6 and same in data set 2, and mode is 6, same in data set 2, because you see 6 occurs twice in the entire data set. And mean, you total 72 divided by 12, that's 6. Here 36 divided by 6 is 36. But does it mean the distribution of this data set is similar around the mean? Is the standard deviation is equal? No. So this is how, when you get a data set, you can quickly understand the sample that you have taken is how much variations it's happening from your overall population. Okay, so I have put the formula. It's very simple. You can use equal to var and then select the entire column which you have a data set 1. Then Excel gives you the variance as 10. You can apply the formula that we have seen in the before slide. So the variance is 10 for my data set 1. That's the squared deviation from the mean of every data point, and the standard deviation is 3.16. So what I mean is, if I pick any data from this data set, maybe 2 or maybe 10 or 9 from the data set 1, my understanding is somewhere the sample is just 3.16 away from my mean, which is 6. Okay, say for instance 9, so my standard deviation is 3.16, so 6 plus 3.16 is 9.16. Yes, 9 is within that. Okay, or it may be you can take 4 or 3. 6 minus 3.16 is again somewhere around 2 point something, and your 3 or 4 lies between that. So your sample definitely, most of your sample, most of the data set, the data in this data set is around 3.16 away from 6. That is our understanding. In data set 2, you can see the variance is 2 and the standard deviation is just 1.4. That means most of my data from this data set is just 1.4 away from my mean. So if I take 4 and 6 minus my 6 is the mean, and if my standard deviation, if I put minus 1.4, so you should be getting somewhere around 4.6. So 4 is near to that. Even 5 definitely is between it. And then similarly 7 or 8 is just 1.4, an odd difference from 6. So most of your data in this data set falls between plus or minus of 1 standard deviation. Okay, and I will let you know how the empirical rule falls in it. But if you can just understand, this is your data set 1, which has many data in this observation, and there's a data set 2 which has few data in the observation. Just by understanding, if they say the data set 1 also has mean of 6 and data set 2 is also 6, it does not mean the distribution of the data is same. That's what we are trying to understand from here. So that is why variance and standard deviation is very important to be computed from your data set first. Okay, now that I have a standard deviation, is there a formula? Try to understand where is my sample will be. Okay, can I predict, if I've taken a sample, can I predict how much distance this could be from my mean? Uh, so empirical rule applies there. What does empirical rule says is, if your data is normally distributed, right, it's not very abnormal, you have a lot of outliers, nothing like that, you have done a little data sanitization and your data is normally distributed, if you see, then what empirical rule says is 68% of your data should be plus or minus 1 standard deviation from your mean. Okay, that means if my mean is 6, so it should be either on the 5 or on the 7. 68% of my population should be within plus or minus of my mean, standard deviation from my mean. The next apply is 95% of my observation should be plus or minus 2 standard deviation from my mean. And with vast majority, which is 99.7%, should be plus or minus 3 standard deviation of my mean. Let's go to our data set. If you can see data set 1, it has a lot of observations, right? And the standard deviation is 3.16. Okay. So if I take the first rule, plus or minus 1 standard deviation, so 3.16 plus 6 is 9.16, and then minus 6 is somewhere around 2.84. So most of your data set, means it's more than 68% actually, is lies between this area of the distribution. If you put plus 2 of 3.16, that means 6 plus 3.16 plus 3.16, that is, you have crossed almost 12, right? And similarly, if you minus it, so that means 95% of the data set should be within that area. That's what empirical rule says. In our case, almost everything came under that area. Similarly, for data set 2, your mean is 6 and your standard deviation is 1.4. So 6 plus 1.4 is 7.4 and 6 minus 1.4 is 4.6. So if you can see, most of the area is between that. And then if you put plus 2 times standard deviation, means 6 plus 2.8, which is 8.8, and 6 minus 2.8, which is around 4 and odd. So almost all your data set came under this, which is 95% of the expectation of your data should be plus or minus 2 standard deviation. And if you put plus or minus 3, almost everything in both the data set 1 and data set 2. This is what explained by empirical rule. So if I pick up an observation and if it is somewhere around plus or minus 1 standard deviation, my understanding is it is within the 68% of the population. And if I want to cover the 95% of the population, I should consider plus or minus 2 standard deviation. And if I want to consider the entire 99.7, then I have to take plus or minus 3. But generally in the real-time situation, you'll always mostly go to 95%. They will call it as confidence level. So if you have taken a sample from your data set, say for instance, we have taken 5 from the data set 2, right? And it is plus or minus 1 standard deviation. Or you can say it is plus or minus 2 standard deviation, say 4 if you have taken. I would say by 95% confidence, whatever 4 reacts is what the population also reacts. That's what I would try to say. Okay. And in health sectors and medicines, pharmaceuticals, it will be 99% confidence. So obviously they will try to cover the entire population. They cannot give that much of error. But in a general production unit, or you're trying to measure sales, you're trying to project what would be the customer footfall, then most of the cases it is with 95% confidence level you try to pick it up. So this is the base that you understood what is data set. You understood what is mean, median, mode out of the data set. You have seen what is variance, what is standard deviation. Then applying empirical rule, you understand where the sample will lie from your standard deviation. These are the basics. Once we understand these very clearly, there are many other topics which helps us to explore more about a data set, and we can try to project a figure, maybe sales. We will try to predict where could be the next impact it can be with the prior data sets that we have. So this is something interesting with statistics. If you see just a formula, it's a very boring stuff, but when you're trying to apply in your real-time life, almost everywhere we will try to use stats. You try to average and think how much of uh, this customer paid against how could be for the next month in your any real-time businesses. And it can be applicable in a large production scale businesses where you cannot take the entire population to measure. You take some samples out of it. There are some measurements how much sample you should take, but once you take the samples, you would know how much this samples is trying to predict, and that would be the similar to the population. So this is widely used in stats. This is just a very basics topics that we have picked up. We will explore more, but I wish this is of much use for you. uh, Try to explore more, try to apply this in many of your data sets and try to understand it more clearly. That much for today. Thank you for watching.